function. I'm given the number of units. This is m in the number of units. T is the number of years. And I'm given between 0 and 40 years of employment. That's all I have to do. T, m of t, of course, prime first, and m of t, and 0 to 40. That's it. I have to find critical numbers. It's always defined. It's a polynomial. So m prime of t will be negative 4t plus 100. When I set this equal to 0, I get negative 4t equals negative 100, or t equals 25. I found it. It's in between 0 and 40, because if I get 75, of course not. That's not the case, but it cannot be. But anyway, let's say I get 75. I'll say I only can study the sign. I cannot, the derivative does not change sign in there. Okay, so now I have to study the sign. Very easy. I plug in 0, the sign of the derivative. So I plug in 0. So what is the sign here? Positive, very good. What is the sign over here? Let's say we plug in 40. Negative 4 times 40 is negative 160 plus 100. Just the sign.
Negative.
That's it. At this point, I take the function, I plug it in, and I plug in 0, but that's easy, 180. I have to plug in 25 and get this number here. And I have to plug in 40 and get this number here. Because I'm studying the whole thing. You can say, but haven't you come up with the answer already? Yes. But I have to show that this is indeed increasing to this number, and this is indeed decreasing, because these two rows have to work well together. Otherwise, I have a huge error somewhere. So negative 2t squared negative 2t squared, and then plus 100t, and then plus 180. I'm checking, negative 2t squared plus 100t plus 180. Good. What I want is 25 and 40. That's it. So at 25, I see 1430. And at 40, I see 980. Now I know that my table is correct, because from 180 is increasing to 1430, and it's decreasing to 980. Now I have to identify what this point represents, which I know it's a relative max for sure, or local max, but also we'll see in a moment. And what does this point represent? So remember the y values, 180 up to 1430, down to 980. You can say the problem is not asking you to find both. True. I just want to edit in because we studied that thoroughly already. So can anyone tell us? What does this point represent? What does this point represent? What does this point represent?
Does the 180 one, does that represent the absolute minimum?
Oh, awesome. Excellent. Indeed, the absolute minimum. You can say you're not asked to do that, but I want to make sure that my table works correctly. Perfect. What does this represent? We already know it's a relative max because the signs of the derivative. Up,
So
down.
maximum.
Yes, and the absolute. So the productivity is 20, the maximum for these employees in whatever they are producing, 25 years into their employment. 25 years later, they become the best. Okay, what about 40, 980? What type of point is this?
Nothing.
Exactly. Nothing, because it can only be an absolute. It cannot be absolute max because there is a number that is larger. It cannot be an absolute min because there is a number that is smaller. So this at the end point is nothing. That's it. Awesome. So now I would like to move on. The next section deals with optimization, which is exactly the same thing, finding max, min, all the same. So back to the book. I have nothing to say, we just have to practice. Page 328, 328. So let's see what interests us. This is even easier. We're not really asked to look at a closed interval. We're asked to just maximize, find the maximum, find the minimum. That's all it means. I would like to look at a cost, revenue, cost, and profit, but we can choose from here. And anything else that might be of interest. Maximizing volume, if we're given a piece of cardboard, 20 by 20, and such, we create a box.
We do that one?
Yeah, which one?
19, right?
19. So let's look at 19. So let me copy 19. And this is on page 329. And which page am I on? I am on page 6. Good. So from a thin piece of a cardboard 20 by 20, okay, squared. So 20 inches by 20 inches. Square corners are cut out so that the sides can be folded up to make a box. What dimensions will yield a box of maximum volume? Max volume. Okay, and what is the maximum volume? Perfect. So imagine, let me see where I have a sticky. So let's say this is 20 by 20. That's a thin piece of cardboard. And I remove squares, identical squares from each corner. If it's a square, it's x by x from all 4 corners. Of course, it had to pick up my page. Okay, so then we will fold the sides. No, my box will not hold anything, of course. I'm just explaining how to do it. So now we have a box. So we removed x by x. So something like this. X and x. X and x. X and x. X and x. How does it look now? It looks like this. So this is my box here. And this was initially with all the corners in there. So how do we proceed? We're asked to find, first of all, I need to determine the length, which will be the same with the width because it's a square. If they were not equal to each other, then it would have been a different story, but they are equal to each other. So, and I remove x. Obviously the height, what is the height?
Money.
20.
How much?
X.
Good. The height is x. What is the width? Which is the same with the length. So this.
That's 20.
So
Oh,
this is the width,
oh.
and this is the length. Because I fold it up.
Minus 2x.
Yes. 20 minus 2x and 20 minus 2x. Awesome. This is the key word here. Can anyone give us the volume of this box?
X times 20 minus 2x squared, or cubed.
That's it. That's it. So it's area of the base area of this rectangle, 20 minus 2x times 20 minus 2x, of course, squared, times the height, which is x, indeed. And this is a function of x. Awesome. Great job. Perfect. So now I'm asked to find the maximum of this function. It's everything I learned in this chapter. I will expand it or just differentiate it. Maybe that's even easier, not to expand it. So I have my table. Of course, x cannot be just anything. Maximum is 20. It cannot be 20. You know that, because if I have x 20, then I don't have a box. So it cannot even be 20, but I wrote 20 there. So v prime of x and v of x. So let's go directly to finding the critical numbers, v prime of x. So I have a product, function 1, function 2. Careful how we differentiate. First function prime is 1 times the second one plus the first function multiplied by the second function prime, 2, 20 minus 2x to 2 minus 1 times the inner function prime. I always have to say times the inner function prime, which is -2. I have to clean this up, set it equal to 0 to find critical numbers. Ready for that? Okay, so what I would like to do, I would like to factor out 20 minus 2x. I took one out, so one is left in. This is out. So I have -2 times 2, which is -4x. So finally, 20 minus 2x, 20 minus 6x. Fine. Finally, set it equal to 0 to find critical numbers. So v prime of x is 0. We have two possibilities. Either this factor is 0 or this factor is 0. Okay, so this one, 20 equals 2x, so x is 10 and inches. And this one, -6x equals -20, so x equals 20 divided by 6, or 10/3 inches. So now I put these two values, 10/3, in the correct order, and 10, but I have to think for a moment. How can x be 10? So if x is 10, so if this is 20, then x is 10. I don't have a box, right? So this cannot happen. I'm going to write 0, of course, but it cannot really happen. This is the only option. Now I have to study the sign of the derivative, and I have to find this value here, because I have to put it in the function. So 10/3 in here, when x is 10/3. So in other words, what does it mean? It means that if this is 20 inches, this little corner that I have to remove is, sorry, is 10/3 by 10/3. 10/3 by 10/3. Everywhere, all four corners. And this goes away. which is 3 inches and a little bit, 3 inches and a little bit, and 3 inches here. So from 20, I subtract 6 inches. So that's okay. That works. But 10 and 10 cannot be, because this is 20, and this will be 10. I cannot create a box if I remove 10 by 10. So that will not work. So obviously over this, it doesn't even make sense. Good. So now let's study the sign of this. That's the derivative. We want to plug in 0. 0, 0. What is the sign?
Positive.
Yes, of course. Thank you. And now let's plug in 10. I cannot because this will be 0. So let's plug in 9. 20 minus 18, positive. 20 minus 56, negative. That's all I needed. So obviously this should be the absolute maximum volume. But I have to convince myself. I have to plug in the original function 0. When I plug in 0, of course, this will be 0. I will plug in 10 just to convince myself that everything is okay. And I will plug in 10/3 and put it here. And that will be the relative max, the absolute max, this value. Where does it occur? When x is 10/3 inches, the absolute maximum volume will be this. But I have to plug in the function. So in y equals, I have x. I have parentheses, 20 minus 2x. Close, don't forget the power. So let me mute you, sorry about that. Sorry about that. Good. And now I will plug in 10 divided by 3. 10 divided by 3. See what I get. And I will also make sure I plug in 10. I get 0, of course. Oops, I forgot to copy. So what was the absolute maximum? 592.59 measurement unit, please. 59259. Was it 59 or 29? I didn't see. 59, yes, correct. Okay, measurement unit. Can anyone
Is it
give?
cubic inches?
Very good. Of course. Cubic inches. Thank you so much. It's volume. Awesome. Excellent. Any questions here? Would you like to look at a cost and profit and whatever, revenue, or move on?
We can look at one of those.
Okay, so let's choose one.